It's not logical because it doesn't necessarily make sense. And let's go back to the pizza analogy, and I'm going to use a square rather than a circle, just because I don't want to deal with pie too much. Pizza pie. All right. So the deal is this. Okay, so you go to Papa John's and you get their square pizza, which I don't know if they even have. And you know they offer this size here, which is a 10-inch square pizza. Okay. Got that? And they offer a pizza that is twice that size. I suppose I need to make this a little bigger. Let's just make it here for times a bit. Twice that size. Twice that size would be how big, Keith Stewart? Do the math for me.
20 by 20.
20 by 20. How did you know? Okay. Now let's stop there just for a second. First of all, what is my scale factor? Or the question would be, what do I multiply this dimension by to get the new dimension?
Times 2.
Yeah, my scale factor is 2 times bigger. Righto, reindeer? Everybody's good with that? Tell me there. Okay, with that being said, let's look at this. First of all, let's look at how the perimeters compare. Not that anybody ever cares about the perimeter of their pizza. What is the perimeter of the small one? 10 plus 10 plus 10 plus 10. The perimeter is, I know that math is hard, so let me pick somebody that probably can handle that math. Jaden. The perimeter is 40 inches on this one. The perimeter on this one, 20 plus 20 plus 20 plus 20. Another Einsteinian sort of person out there, Isabel? 80. So, if the scale factor was 2 times bigger, how much bigger is the perimeter? How many times bigger is the perimeter? To go from 40 to 80, you multiply by what, Ty?
2.
2. So the perimeter is also 2 times bigger. Whatever the scale factor is, that's how much bigger the perimeter is. To which you're going to say, wow, that is somewhat of a shocking revelation to me. Well, don't get too big for your britches, as my mom would say. Because, what's going on here? Because just when you thought it was safe to go in or out of the water, let's look at how their areas compare. What is the area of Mr. Small Pizza here? 10 times 10 is, Danny?
100.
This is 100 square inches of pizza. What is the area of the big pizza there, Brianna? 20 times 20 is? Twenty times 20 is? Elijah?
400 inches squared.
Yeah, 20 times 20. I'll do the math here. 400 inches squared. Which is not logical to most people because if you double 100, you should get 200 square inches. But that's not the case when it comes to area. Okay, when it comes to area, how many times bigger is 400 than 100? How many? 4 times bigger. Area is 4 times bigger. So when the scale factor was 2 times bigger, the perimeter was 2 times bigger, but the area ended up being 4 times bigger. Okay, and the reason for that is this, because when you do area, you're not just doubling one dimension that gets multiplied, you're doubling both dimensions. This one this 20 was times 2, and this 20 was times 2. If you double something and then double it again, when you multiply, you get 4 times bigger. It didn't matter with perimeter because we were just adding, we weren't multiplying. You add the sides together for that. But when you do area, you multiply and you double and you double. So doubling gives you 4 times bigger. Now let's say my pizza, let's do volume of this pizza. Let's say the pizza is 1 inch thick here. If I double 1 inch thick, what do I get? Well, my new pizza is 2 inches thick. So if we're talking about volume of my new pizza here, what's the volume of this small pizza? 100 times, I mean, you do this times this times this, so it's 100 times 1, which is, this is 100 inches cubed. Sorry. What's the volume of this one? 20 times 20 times 2. 400 times 2 is? Somebody? 800 inches cubed. So the volume went from 100 to 800. How many times bigger is that? Elijah? 8 times bigger. So when I doubled its dimensions, the perimeter was doubled, the area was 4 times bigger, and the volume was 8 times bigger. Why 8? Because volume, you're multiplying 3 dimensions, and each of those 3 dimensions were doubled. If you double, double, and double, 2 times 2 times 2 is 8. I doubled this, I doubled this, and I doubled that. 2 times 2 times 2 is 8. Okay? Now, the rule of thumb is this, and this is going to go way over most of your heads right away, but eventually you'll catch on to this. Okay? The key to all this is your scale factor. Whatever your scale factor is, your perimeter is the same. Whatever your scale factor is, your area is the scale factor squared. And whatever your volume is your scale factor cubed. And that's kind of the most important thing, and I don't expect you to pick up on that right away, but eventually they'll ask it so many times that maybe, just maybe you'll catch on to that. So let me throw this at you. Let's start with the cube again. And not use 2 because 2 can sometimes be kind of misleading. Let's make this cube 1 inch by 1 inch by 1 inch. This time let's use a scale factor of 3. So now it's a 3 inch by 3 inch by 3 inch cube. Sorry. How many times bigger is the volume going to be of the big cube than the little cube? Now to answer that question, the first thing you think about is what's my scale factor? What do I multiply the dimensions of the one by to get the other one? Isabel? My scale factor is 3, or times 3 if you want. And then you go back to what I just said. If I was looking for perimeter, which I'm not, the perimeter would also be 3 times bigger. If it was something I was looking for the area for, the area would be how many times bigger? Remember, it's scale factor squared. Scale factor squared, Brooklyn.
6.
Nope. 3 squared is not 6. 3 squared, Drew, is 9 times bigger. But I'm not looking, I'm looking for volume here. And the volume is scale factor cubed. Cubed. So how many times bigger is this cube going to be than the one I started with? There we go. 27 times bigger. Which, if you look at what the volumes of these things are, what's the volume of 1 times 1 times 1? Volume of that is just 1. 3 times 3 times 3 is 27. You could take 27 of these and stack it in that big thing there. Okay? And it's not logical because people always say, well, this one's 3 times bigger. No, the dimensions were 3 times bigger. The volume is 27 times bigger. That's why when people ask you how many square inches are in a square foot, everybody wants to say 12 because there's 12 inches in a foot. That's not true. Here's your square foot. The square foot is 12 inches by 12 inches. This is 1 foot squared. 1 foot squared. What's the scale factor? Well, there's no scale factor there. Well, there is. It went from 1 to 12. So your scale factor is actually 12. But my scale factor squared is, there are 144 square inches to make up 1 square foot. So all I'm asking you when we do stuff, when they start talking about this, just stop and think and say, not always is it logical to me. It's not the first thing you think of when you do this, and you kind of got to think it out just a little bit. Now, on to today's lesson. Write down this problem. Oh. No, I don't want to do that. Write down this problem. Oops, boy, that wasn't good. I'm not sure what problem I want to do. Okay, here it is. Here's the problem. One square is 50% larger than another square. Then another square. Answer these questions. Letter A. The perimeter is what percent of the perimeter of the small square? The perimeter is what percent of the small square? Letter B. The area of the large square is what percent the area? Is what percent of the small one? And letter C, you guessed it. Oh no, sorry. I don't have to guess it. And like I said, I apologize for this, but there's no easy way to explain this, and it's all about wording of the problem. But as you will see there, how big is the small square? Maddie Marco, how big is the small square? What's it say? Huh? No, it says one square is 50% larger than the other. How big is the small square? It says it's 100. Where does it say 100? Colquitt, how big is a small square? 30? Am I missing something here? Isabel, don't say. Don't say at all. What should make you either both happy and sad at the same time? If it doesn't say, it doesn't matter. If it doesn't say, you get to pick your own dimension and figure it out. Because it'll be the same no matter what dimension you pick. That's the general rule of thumb. So, if I run across this, I smile because then I can pick a square and just pick the easiest numbers I can think of. And before you say 1 is the easiest thing you could think of, 1, yes and no. If given the choice, what I would do, I would pick 10. Just because. So I am starting with the square that's 10. Why 10? Because that's what I picked. There's no other reason. I like 10 because it's a nice number. Well, it's larger, so I can't draw a smaller one because it says it's larger, and it's 50.
What is 50% of 10? 5, so if I make it 50% larger,
Jaden, it's right, because 50% of 10 is 5, 50% larger, so my new square has to be 15 by 15. So far so good, right, kids? This is very exciting, I think. Then how much today? Just regular lunch. Be more exciting if it's how much.
Okay, now I maybe can answer this question. Okay, what is the perimeter of the small square? Let's do that because perimeter of the small square is what? 40, everybody's in agreement there, doesn't matter, inches, feet, whatever. Perimeter of the big square is? 60. What in the- Oh, this is bad. No, I just put some updates in there, but I'm not gonna restart it, I'll restart it later. Alright, the perimeter of this one is 60. Now, here's where I said wording is important here. The perimeter of the large one is what percent of the small one? The perimeter of the large one is what percent of the small one? Now, in order to do that, because I see Fisher looking at me kind of awkwardly, I am, believe it or not, going to go back and draw a little percent ratio box here. Because this is an increase here, right, it's getting bigger, I'm going to make it a percent increase where I have the original plus the increase equals the final. My original square started off being 40. How much did it go up? From 40 to 60 is, and my final then is 60, correct? When I'm shooting out the percentages, my original percent was 100, and I don't know how much the percent increase, and I don't know what the final percent is. The problem is you have to say, which one of these am I looking for? Am I looking for how much, what percent it went up, or am I looking for what percent it is? Yeah, you're looking for this one. And I think you'll be shocked and amazed by the time you finish this up. So I do my little fraction thing, I don't need this middle part here. 100 over what number is 40 over 60? To which you're going to say, somebody? What's my easiest way to do this? Keith? Take the zeros off, I get 4 over 6, reduce it to, well, you could do it even with that 4 over 6, right? 4 times what is 100? 25, so 6/4 is how much? 150. So my final one, the answer to this first one is 150%. What?
It's 66 and 2/3. I said I did laugh.
So you did laugh. Well done. Sometimes you gotta watch that. Okay. Now, stop and think about this for just a second here. Let's go back to what we talked about at the very beginning of class. Until you're mesmerized, Grace. What was my scale factor from this to this? Go from 10 to 15, scale factor of what? 10 times what is 15? Anybody? Huh? No, 10 times 0.5 would just be 5. 10 times what is 15? If you don't know, then do this. 10 times what number is 15? Tyler, 1.5. My scale factor is 1.5. We're looking at the perimeter, right? What is 1.5 as a percent? Because scale factor is the same. Whatever the scale factor is how much that new square is. It's 150% bigger. Alright? Can anybody take a guess about the area? Based on what I said. Scale factor for perimeter is exactly the same. Scale factor for area is, or the new area is, what do you do to the scale factor to get the new area? That's what I thought we were going to start. Let's go back to this. Hold on a second. Maybe this will jog your memory. Sorry. Maybe that'll just mess up your memory. Where's it at? Somebody? Where's my sheet? Where's my thing go? Oh, wait. Don't lose now. Here it is. What's this? Area, you always think scale factor squared. So guess what? My scale factor is what? Guess what my area, when I answer this question, what should I come up with? Scale factor squared. What is 1.5 squared? I know nobody likes to do it, but it is. Anybody? Pi. Which is what percent? I am going to hopefully get 225% when I'm all done, because area is scale factor squared. Let's look at this. What's the area of this one? 100. What's the area of this one? 225. If I plug all that back into my little table here, why don't I have a spot to do that? I ran out of room. That's much better, don't you think? If I plug that into my little percent table here, okay, my original was 100%. How big was my original? What was 10 times 10? Plus my increase, which I don't know. What was my final? 225, right? So this increased by 125. I'm looking for the percent my final one is, but this is going to be hard for you. Watch this. 100 over what number equals 100 over 225? Anybody? 100 times 1, 225 times 1. 5% is 225%. And I know that, I will tell you, if you understand this, consider yourself in one of the very, 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 very few people that catch on to this the first time. Because it will be completely... Oh, we still have 20 minutes left. We could do at least one more problem. No, I'll look for something here. Yeah, look at page 482. This, if you feel like falling asleep now, this will wake you right up. Right. Everybody there? I want you to catch on to this. Who's missing? Why are you missing?
Landon's on vacation, Riley was sick, Riley was and Aubrey's grandpa died. Yeah.
Okay, look at letter A. Read it to yourself as I read it aloud. There are two concentric circles, which they give you a picture of there, on the playground. The diameter of the larger circle is 40% greater than the diameter of the smaller circle. The area of the larger circle is what percent greater than the area of the smaller circle? Now, hopefully, if you're like me, when you read that, your mind is spinning. No idea. Not even an idea how to start it. Well, you don't. You do have an idea to start it. How do you start it? Well, you sketch it out. Now, let me tell you, I told you this, I believe. Did they tell you the dimensions of the circle? No, so you get to draw your own. Secondly is this, listen, focus in on this. It doesn't matter if it's a circle or a square or a rectangle. Okay? If they don't give you dimensions, and it's something about dimensions and percent increases, decreases, don't do it as a circle. Do it as a square, because then you don't have to worry about 3.14 showing up and messing it all up. It doesn't matter whether this playground thing is a round thing or a square thing. All those dimension things are all the same. So rather than drawing a circle, I would go, okay, I have a small square inside of a big square. And the only thing I know about it is the big square. I won't use BS because that's probably bad. Big square is 40% larger. Okay? Big square 40% larger. Well, ladies and gentlemen, we're going to throw down some dimensions here. It doesn't tell me dimensions. I get to pick my dimensions. Your choice as to what you pick. I try to pick 10 because 10 and 10 is 100. That's a percent, a good thing. So if my little square is 10 by 10, how big is my big square if it is 40% bigger? So you need to know what 40% of 10 is and make it that much bigger. 40% of 10, make it that much bigger. What is 40% of 10? 0.4 times 10, 4. So if you take 10 and add 4 to it, my new square is 14s. We are talking about area. So let's calculate areas. That shouldn't be too hard. Area of the small square again is good because the area of that is 10 times 10 is 100. Small square. 100 is the area of the small square. What's the area of the big square? 14 times 14. I don't know if I'd expect you to know that you have it. It is what? 156. So I got my areas, right? Now, what does the question ask me, Jaden? Shoot, since you answered that last one correctly.
How much percent is bigger?
Read the last sentence. The area of the larger circle is what percent greater than the smaller one. So if you're doing our percent box, watch the magic of this, children. Again, this is a percent increase. So you've got your original, your increase, your final. This is the actual numbers here. The original square was 100. It ended up being 156, correct? Which is a percent increase of 56. The area of the large circle is what percent greater than the area of the smaller circle? What's my original percent? Am I looking for what percent increase it was or what the final one is? Right, did I not see the word greater? Is the word greater in there? If it's asking for how much greater it is, that's the increase. You don't need this. And maybe you can do the math there. What percent increase is it? 100 over, what number is 100 over 56? How about that? 56% greater. 56% greater. Shazam. Love it. Alright, we'll stop.